All right, are you ready for your boundary question? Today, we are going to learn all about the states of matter. Do you know the states of matter? We have three. Hint, hint. Try to answer them now. All right. Hopefully you were able to tell me that we have three states of matter: liquid, gas, and solid. If not, that's what we're going to learn about today, so no worries. We're going to jump right into it though, and I'm sorry these look so funky. Hopefully you can still read the words. Perhaps I will fix them for class tomorrow. Matter, as we defined yesterday, is anything that has mass and takes up space. Matter is observed in one of four states. We're not talking about plasma today. I did forget about that one. We have solid, liquid, gas, and plasma. And then let's talk about kinetic energy, because this plays a main part in why we have the different states of matter. Kinetic energy is the energy of motion from the highest molecule to the lowest as far as kinetic energy goes. Gas has the highest amount of kinetic energy, liquid has the second highest, and solid has the lowest amount of kinetic energy. We're going to learn today that the amount of kinetic energy that's input into matter is going to impact what state the matter is actually in. We're going to start off with solid. So our solid is the state of matter that has a definite shape and volume. These molecules are arranged in a regular repeating pattern. They often look cuboid or cube-shaped, and they look nice and arranged. They're very orderly. These are very closely packed together, but they do vibrate just a little bit in place. One of my questions here for you is, am I adding or taking away heat when I am going from a solid to a liquid? Hopefully you are able to tell me that as I add heat to a solid, like a solid ice cube, it becomes a liquid, so I'm adding heat here. What type of energy is heat? Do you know? Maybe you don't know exactly, but hopefully by the end of the lecture, you'll learn that heat is actually kinetic energy, or the energy of the movement of particles. So as I add heat or kinetic energy into my solid, it actually changes state and will become a liquid. How do I go from a liquid to a solid? Hopefully you'll tell me that we are melting, and from a solid to a liquid, I need to freeze it. So I need to add heat here, or add kinetic energy when I melt, and I need to take kinetic energy away when I freeze. How do I go from a gas to a solid? This one is a little bit trickier. We've learned melting and freezing hopefully all of our lives, but gas to a solid we learned in our hydrosphere unit is called sublimation, when I go from a solid to a gas. And then deposition is when we go from a gas to a solid. That one we haven't really talked about. So those are the arrows that connect our solids and our gases. Let's move on to liquid here. If I'm moving from a solid to a liquid, I am adding heat. So the answer here is I'm adding heat as I move from a solid to a liquid. My liquids have a definite volume but no definite shape. That's why I can pour a glass of water into one cup and it'll take one shape. But if I pour it into a different cup, it's going to take a different shape. Molecules are loosely packed together and can flow against each other. They cannot be compressed, so you can't take a liquid and compress it together. You can see my molecules here look less orderly than those in my solid form. And they have a little bit more kinetic energy than my solid molecules, because these are moving more. What type of energy is heat? So if I add heat from my solid to my liquid, what kind of energy am I adding? Hopefully you remember from the other slide that heat is kinetic energy. So I am adding kinetic energy when I'm moving from a solid to a liquid. Now tell me, how do I go from a liquid to a gas? What's that called? This should be reviewed from our hydrosphere unit, so hopefully you should remember that when I go from a liquid to a gas, we call it evaporation. And when I go from a gas to a liquid, we also learned about this in our hydrosphere unit. We are going from a gas to a liquid, excuse me, is called condensation. So fill those in on your notes. All right, so if I'm moving from a liquid to a gas, am I adding or taking away heat? Hopefully you were able to tell me that I'm adding heat. And then again, what type of energy is heat? What did we say? Hopefully you were able to identify this time for sure that heat is a form of kinetic energy. So I am adding heat, and therefore I'm adding kinetic energy when I move from a liquid to a gas. So when I evaporate. Gas is the state of matter with no definite shape and no definite volume. These molecules are very free. They move around, they bounce around, they move really, really quickly. And they can be compressed, although that's not something I would necessarily ask you. Good. Now just a reminder, remind me if I'm moving from a gas to a solid, what did we call that? Hopefully you remember that we called it deposition. And then if I'm moving from a solid to a gas, what is that? Hopefully you were able to tell me that that is sublimation. Sublimation we talked about when we discussed the water cycle, but we did not talk about deposition. And then here's your goal. So I'm going to show you a series of pictures. I want you to judge if heat was taken away or added during a phase change. So let's do the first one together. So if I'm going from a liquid to a gas, and these aren't on your notes, they're practice. So this is what you should have learned. This is your exit ticket. So if I move from a liquid to a gas, am I adding heat or kinetic energy, or am I taking it away, going from a liquid to a gas? Hopefully you identified that I am adding heat. All right, let's try this one. If I'm going from a solid to a gas, so sublimation, am I adding heat or taking heat away? Hopefully you were able to tell me that I was adding heat again. Now if I go from a liquid to a gas again, and I want you to get used to looking at the molecules and being able to predict whether these are, if I took away the word liquid and I took away the word gas, could you tell me that this was a liquid and that this was a gas? So if I'm moving from a liquid to a gas, am I adding or taking away heat? Hopefully you were, again, able to tell me that I am adding heat, and I'm adding kinetic energy because I'm adding heat. If I move from a liquid to a solid, am I adding or taking away heat or kinetic energy? I'm taking it away, and hopefully you understand that if I'm taking away kinetic energy, my molecules are moving slowly. So my solid molecules are moving much slower than my liquid molecules. If we go back to this picture right here, you can tell that. So my gas molecules right here, because they've got so much open space, they are moving really quickly because they've got a lot of kinetic energy. My liquids right here are still moving, but they are not moving as nearly as quickly as these gas molecules right here. That's because gas molecules have more kinetic energy than liquid molecules, or they have more heat. Okay, so from a liquid to a solid, how about this? I've got a solid where I have very little kinetic energy in my molecules to a liquid where I have more kinetic energy in my molecules. Hopefully you were able to tell me that I am adding energy again. I am increasing my kinetic energy when I move from a solid to a liquid. All right, now we've got these molecules right here compared to these molecules right here. The first thing you would need to do, by the way, I'll ask you to do this, so learn it, is identify if this is a gas, liquid, or a solid. Hopefully, because we already saw this picture labeled, you know that these are gas molecules. You can tell that because there's lots of empty space and lots of disorder. Kinetic energy or heat energy is the energy of disorder. And then hopefully you were able to tell that this was a liquid because while these are a little bit more tightly packed together than these right here, they're not orderly, so they're not a solid. So I'm moving from a gas phase to a liquid phase. Am I adding heat or am I taking heat away? Hopefully you were able to tell me that I'm taking heat away. Good. And that's our last one. So once you have done the notes and gone through these questions with me and really understand it, you can turn the notes in and you're good to go for the day. By the way, this was only part 1 of your assignments. You have 2 assignments to do today. This very first one, and remember, you need to go to modules, not your to-do list. Doing these notes was the first assignment. Your second assignment is right here, and we're a little out of order, is this homework assignment. So you're going to do this, but after you've completed the notes. I'm going to do the first couple ones with you, and then you're going to finish these you're going to finish them on your own. You're welcome to do them with a partner, but you each need to turn in the sheet. So here we've got some definitions of the states of matter, and some definitions of like freezing point, melting point, boiling point, evaporation, condensation, and sublimation, things we've talked about before. That's more of a reference, nothing to do here. And then here we've got a graph, and for questions 1 through 14, you're going to interpret the graph or answer the questions using the graph. For example, number 1 asks you, what is the melting point temperature of ice based on this graph? So you're going to need to go find the melting point, which is labeled right here for you. And you're going to need to tell me what temperature. So temperature is on the y-axis, time is on the left axis. So my melting point right here is 0 degrees Celsius. So for number 1, you would answer 0 degrees Celsius. Number 2 asks you, what is the freezing point in temperatures of ice? Freezing point is not labeled, but if my melting point is 0, where it melts, what do you think my freezing point is? Hopefully you were able to identify that it melts at 0, but it also freezes at 0. So 0 is my freezing point. What is the boiling point? So you're going to find boiling point on the graph. Number 4 through 9-ish get a little bit trickier. So you're going to use the letters, so like A, B, C, D, E, to identify different parts on the graph. So number 4 asks you, what letter on the graph corresponds to only liquid water? So we know that right here, we're at our melting and freezing point at 0. But as you notice right here, you see an increase in temperature because my line is going up. So it's no longer a solid right here. All right, so you can even see here on the graph, it labels forming liquid water. So the letter that corresponds to only liquid water would be C, because C is labeling this line that goes up right here. And then you're going to keep answering all these questions together. If we go on, so don't forget 14 uses that graph too. I need you to explain what happens at each section of the graph. So the letters are corresponding to sections too. So what's happening here at A? So for A, I might write something down like my liquid or my ice. I'm adding heat to my ice here and melting my ice. So my ice is becoming warmer, and then it's undergoing a phase change at line A. That would be a good answer for A. Then you're going to do the same for all the other sections. Then you're going to use the information at the top of page 1 to answer the questions. So these definitions, they're going to help you answer these questions. Don't forget that you need to draw a picture. My green box here says that you are going to use the drawing feature to create pictures in these boxes. And then the last part of the worksheet asks you to match each question to the best answer. So this is a little vocab review here. You're going to use each of them once, so they shouldn't repeat. All right, guys, if you have questions, please email me. Have a great day.